Go ahead, Zach.
Yeah, sorry. So the primary things to concern about within phenotyping are having an atlas instance and then running cohort diagnostics, which is in our package. And so one of the major things about these is that we have our atlas instance stood up within Hopkins Safe Desktop, and that's our connection within our myositis OMOP database. So that much is set. That much is well and working. But because of the limitations that we need to stay within Hopkins' safe desktop environment, that enforces a bunch of other restrictions that have like made issues within our development in R. So I'm going to share my screen without my sensitive information showing. And so let me do this real quick. So this is our R package, or this is our script being developed. So one of the main things is that within Safe Desktop, at Hopkins at least, the R version is fixed at 4.0.5. And this is a bit older. And so one of the workarounds that we need to do was running a older version of cohort diagnostics. And Will Kelly, this is the point where you can pop in. There is a workaround that we've gone to get into 4.2.2 of the R version, which would allow us to run the most up-to-date cohort diagnostics version. However, there have been some issues that the workaround causes additional issues in terms of running the rest of the package, is what I found.
I see. So when you expressed issues with executing cohort diagnostics 2.4 on the R 4.0.5 environment, I tested it in with R 4.0.5 on cohort diagnostics 2.4 in another environment that I have access to, and I realized I was able to reproduce the same error message that you observed. And the workaround for that was to change an parameter on cohort diagnostics execute function, run orphan concepts set to false. And when I ran with the run orphan concepts set to false, I was able to get it to full completion. Did you get a chance to follow that? Yes.
I tested that, but I still am getting the same error. So I have it
Okay.
pulled up here. I can try to run this one more time. But basically, I did a bit of a deeper dive into the cohort diagnostics code, and essentially this run orphan concepts parameter. So if we look at the trace back here, it basically is executing diagnostics, and then it's this portion right here, which is the write to CSV, in the final stage of.
Okay, I see. So it
So it
sounds like we
is.
need to either you have, from a technical standpoint, you have either two options. One is to try to see if that other alternative environment, which is not, I think you said the safe environment, is the way to go. The unfortunately, Core Diagnostics 2.4 is not supported by anymore, but that's why we promote the use of 3. Whatever the current version is. But for this particular scenario, we'll try to work with, and maybe if you are not able to use the version 3.x because you're not able to execute it on the other alternative environment, I could request the current maintainer of Core Diagnostic, Dr. Jamie Gilbert, to please join us and help you with this issue at a later point. Is that reasonable?
That sounds good. And I think Will can speak to this more because in this separate instance, basically, we've been testing a slightly different variety in which, in this case, we actually do have 4.2.2
okay.
in safe. However, this has led to other issues. The main thing being is at least, and this has like been a much more recent development. This happened maybe 2-ish days ago. And I don't know if Dr. Meckley mentioned it. I am a full-time student, and I was at my throughput capacity in terms of working on this. So once we made the crack to develop this versioning, my Java instance broke. So the
I see.
workaround that allows us to get a newer version of R seems to complicate the Java Insafe desktop, in which case the package breaks, but for different reasons.
I
see.
will see what I can do to try and troubleshoot that on our end so that we can eventually run this on the latest version.
Yeah, because in the ideal case, Core Diagnostics is the most up-to-date, Java is working, R is the most up-to-date, and in which case, that seems to be the only technical error we are running into, because we are able to generate our cohort, able to execute diagnostics up until that very last stage.
Did you get any
It's-
output in the version 3, or was the version 3 was
Yes.
not even executing because it was because of the Java error?
Yep. So we actually are able to generate all of these. And if we want to
Okay.
dive a bit deeper into any of these particular files, we can.
So what was the error message in version 3?
In version 3 says that it can't identify where the Java source files are, even though I verify that they are readable and at the location it says. And that might be just a technical standpoint from our particular environment.
Yeah, so this might be something relatively simple. It sounds like Core Diagnostic did not even start for version 3. So it might be some environment setup issue that could be solved in like 5 minutes of consultation with somebody else that is not me. So maybe I'll set up the connections and we can follow up later. And so maybe depending upon your bandwidth and availability, we can follow up. Because you're continuing to have an issue with version 2.4 with run orphan concepts equals to false, I think it will be a much bigger lift to even figure out what's going on there. And because it's an unsupported package version, I don't think we should continue to spend our energy on that one.
Absolutely.
Okay, so I would like to shift gears to the next topic, which is the actual clinical idea that we are trying to phenotype. So I've received the output from your initial run on 2.4, and here is I'm going to share my screen just to share what's going on. So here on my screen is data.odyssey.org landing page, and these are all the shiny apps that are in data.odyssey.org. Oh, so on here, I've started a new one called Phenotype Phebruary P7 Dermatomyositis. So Phenotype Phebruary P7 Dermatomyositis, and if you notice, there is a suffix here called V2.4. That's the output you gave me. You gave me some files, the same CSV files that you received before you got the error message. So we have something. Now I have two executions here. The ones with the prefix Pheb Phenotype February 2023 are the two JSON specifications that you shared with me. This was directly from your output. So this 577 is the ID of your instance, as in your instance. So you gave me some output, and the key output is that in your CDM, and I just gave it a generic name, there are 794 people who met your cohort definition logic. So that's the one key insight. So you have 794 people in your data source. None of the other diagnostics has any values in it, results in it, because nothing else has actually run. Now I took the same cohort JSON specifications and run on a data source that I have access to. Now I've not run. I've not looked at the results at all, so I'm looking at it with you for the first time. There were two cohort JSONs that you shared with me. One was labeled as myositis sensitive, another was labeled as myositis specific. So I called it as such. There has been no change to your cohort definitions at all. It's used as is. So there is dermatomyositis sensitive and dermatomyositis specific. Just for the group, because there is lots of people on the call who are looking at it for the first time, I'm just going to call out what these are. So there is a sensitive definition, a specific definition. This is the Atlas instance of the Odyssey Phenotype library. So here, I've copied it. This is the cohort JSON. So there is an entry event criteria, and there are some inclusion rules, and the exit criteria is till end of observation time. Essentially, what that means is once the person ends, they will continue to stay in the cohort as long as they're observed in the database. So there is a concept set expression, condition occurrence of DM, and when I click on DM, these are the concept sets code, or actually code, that was selected here. So there are 4 codes. None of the options here has been selected, and so you have 4 concepts, resolves to 4 concepts because the formula does not require any descendants. So there are 4 becomes 4 here, and they get mapped to several other source codes. So here's the expression. That's the standard codes in SNOMED format that's resolved, and those are the source codes that are mapped to the standard code. So that's where the ICD-10 codes and the CPT codes are, whatever gets mapped is here. Just so you got the entry event criteria, but you also have inclusion rules. So you allow people to enter, and then there are a set of rules that limit people further. These are the set of rules that allows people to stay in the cohort. You've said they should have another code. Essentially, you've said they should have another code of dermatomyositis, and that code can happen anytime, starting all times prior to up to 365 days after. And that's your definition. Now, this particular definition, which is called sensitive definition, I have run on another data source. And in this data source, Optum extended DOD, which has a denominator, I think, of 80 million people, 14,000 individuals were identified. So this is the same definition, the sensitive definition that you provided, which has 794. So we have in another data source in the OHDSI network with the exact same definition, considerable more people that met the criteria. The second definition that you provided was what was called as a specific definition. So that specific definition, which has an ID of 303, I'm going to go to the Atlas instance to look up what that is. So it is similar to the previous definition, but with some additional modifications. So there is the same entry event criteria called dermatomyositis. There is requirement that they have a second occurrence of dermatomyositis. There is requirement for immunosuppressant medications, and this should be within 180 days of the diagnosis. So within 180 days of this, and they should have an antibody test. So an antibody test, one of these long list of antibodies that was selected. And I'm assuming these are antibodies that are specifically tested for this particular clinical idea. So this is the cohort definition it makes sense. So you have the previous definition that let's call it which is a sensitive cohort. You built on top of it by adding additional rules. And if they met the previous criteria and they met the additional criteria, they are in. So you think your assertion is this improves the specificity. So when I do not have the results from your data source because it did not execute on your data source, but the same definition did execute on another data source. And that one led to almost 0 counts here in this data source. So the finding for me is when I toggle to another user interface for the same specific definition, here's the 2 data sources. The sensitive had 14,000, the specific just dropped to almost to 0. And that, this is probably because of data source specific issues. So I'm going to so I don't even have an attrition rule. So I'm wondering. Oh yeah. I do not have an explanation for this. Maybe even that one has bombed. That is so. What I'm observing here is I'm looking at this output with you for the first time. So what I'm observing here is in version 2.4 of cohort diagnostics, for this particular definition, there was no output, not even attrition rule. So I can't even tell the number of people that met this entry event criteria or this. So it might very well mean that this cohort expression is flawed in some ways. And because it is flawed, it is not running. And it could be because of various reasons. But so we have to think about that as to why that is happening. Another piece of information I want to give you all is I took the same definition and I ran it on another data on several data sources that I have access to, but they ran it on a more recent version of cohort diagnostics. So instead of running it on version 2.4, I ran it on the recent release of cohort diagnostics. So I'm opening up this link. So Phenotype February 2023 P7 Dermatomyositis without the suffix. In this particular case, I am going to go. So here it does. You cannot. Your output is not here because your output was part of V2.4, and obviously that is not compatible with this output. So I'm going to go to the cohort counts tab just to see. I'm going to select all data sources. My question here is, are there any that the specific definition, does it lead to counts in any data source? Now I'm seeing in one EMR data source, I see 10 records, but in almost all data source, there is 0. This usually implies between more than 0, but less than 5. So there's one data source that led to 10 people, and there's one data source that led to, between 1 and 5. So that this cohort definition, when applied to 10 data sources that a data partner has access to, practically led to no records. It's indicating to me that the specific definition will not work. And we have to work on some way to change it. So here is the attrition diagram. So there is the insight here, the main insight for me here is this cohort definition is valid. It worked. The reason why you didn't get anything in the previous app, the VD2.4 app, was because there was no records at all in that data source. In one of the data sources, this one is an electronic health record data source, there was some individuals. In terms of attrition, it shows that of all the people that I'm going to show with this one, there were 12,436 individuals who met the entry event criteria. That means they met this criteria. But when we apply the 2 occurrences immunosuppressant and antibody rules, the attrition dropped. So 12,436 became 9,524 because only about 3,000 more people, 3,000 people did not have a subsequent code of inflammatory dermatomyositis. Regarding the use of immunosuppressants, of the 9,524, 7,000 people had an immunosuppressant. But as soon as you apply the antibody rule, that became almost 0. And that's the insight here. So if the antibody rule is where the biggest drop is happening in the specific cohort definition. So it could mean that the antibody rule itself has an issue with it, or that people do not have antibody testing. And I do not believe the latter is true, which is people do not have antibody testing. I believe there was some issue with the cohort definition. And that's basically my initial gist review of your cohort definitions.
That's really helpful, Gowtham. Thank you so much. In hearing you kind of go through it all and seeing it in real time, the biggest parallel, I guess, is to the lupus phenotype that was done on Monday. I think Joel and Janie kind of getting to this, similar. These are both rheumatologic conditions. They're both relatively rare. They both, have these kind of sensitive and specific phenotypes that you can build, and they both rely on testing. So this autoantibody question came up with lupus as well. And I know some databases don't have labs and test results, which is obviously a limiting factor. I was reading the thread and it looked like there might be some strategies to deal with that, to maximize the data gained. So I think we'll have to kind of rethink this and maybe troubleshoot the antibody elements of this phenotype, because it would be very nice to find a way to include it at least in one of the phenotypes.
Yeah, absolutely. So so if you were thinking of, now that we are in the box of trying to, so one thing we have learned from looking at data sources on the report is this rule is not working. So we need to change that rule. So let's think about ways to change that rule. So Dr. Macaulay, I'm going to ask you this question. If you have a person who's got the diagnosis of dermatomyositis 2 times and are on some immunosuppressant medication, if they get antibody tested, just the testing, we do not know the results, just the occurrence of a test, would you use that as an indicator that somebody, a clinician, suspected this enough to have them tested so it improves my specificity?
It would probably incrementally improve the specificity. It wouldn't markedly improve the specificity as if we knew the results, but it would probably help the specificity, yes.
So one approach would be to split this rule into 2 components. And we could say rule number 3 and rule number 4. And rule number 3 could be performance of the test. And rule number 4 would be performance of the test with a positive result. That way we can check how many people actually have the test. And obviously, if they don't have a test, we wouldn't know if they have a positive or negative result. If you observe that only 10% of the people who have the second diagnosis and are on immunosuppressant have the test, then we have a major problem in our hand, because you would assert, like Danny asserted, we're not gonna diagnose somebody with lupus without an antibody testing, right? So I would suggest we split, we create a version of this core definition where we split this particular rule into 2 components. One is make a list of all the antibody tests and just check if they have been tested. What are your thoughts on that approach?
I think that's a wonderful idea.
Okay.
Because I am curious across databases, how many tests are even ordered, and then to your point, of those, how many are positive? But we kind of need that granularity. Yeah.
Okay. All right. So so that's one approach that we can do in terms of phenotype development. And this can be done after this call, or we can continue to do it now. We have 30 more minutes in the meeting. So would you like to, because we have made a decision that we want to evolve the definition, would you like to go through the definition from top to bottom, just to see if there is opportunities to further refine it?
I think that'd be a great idea if everyone else is time willing.
Absolutely.
So Zach, my only pause was because I just wanted to make sure that we were maximizing our troubleshooting for your issues as well. So as long as we've done that, and I think we will, I think there's some off-call stuff we'll do after this. That sounds great.
Yeah, so in terms of the contribution that I can make, my technical abilities is good, but it's limited after a certain point. And for the issue of the Java, I would not be able to efficiently help you. Maybe somebody else from the community has better experience.
Got it. Yeah, so if we can maximize the remaining time on the call, I think we're all for it.
Okay. So some thoughts in terms of dermatomyositis. We are anchoring on the diagnosis, which is a reasonable approach. There could be an alternative approach of like the comments that Dr. Andrea Knoll made for anaphylaxis. We could enter index on a visit. a rheumatology visit, for example, or something like that. But I think this is good enough. Based on this is my personal opinion. Now, in terms of the dermatomyositis definition, and I'm going to do something here. So one thing I just realized is the UI of this is not what the UI I was expecting. And the reason for that is because this is showing me version 2.1.1, which is not the right version. So I have to go to a, just give me 1 second. I'm just going to change screens.
Sure.
And it won't be very long, I promise. All right, I was just gonna bring it in the box. So Atlas as a tool has an issue with holding on to the cache. So my computer that I was sharing the screen had not refreshed its cache. So it was still using the cached version of Atlas, which I have to refresh. So here is, it's version 2.12. That's what I want. Okay. So it's the same Atlas instance. And we are now in your same cohort definition. We're going to click on this. And in 2.1.2, there is a new tab, which is called recommended. And this recommended basically looks at the vocabulary, and based on a certain set of algorithms, it will recommend alternative codes for you to choose from. Now it's your decision whether you want to do it or not. The goal here is to make the first approach is to make this as parsimonious as possible, and use the vocabulary to your advantage. So the first step, when I click on this and I look at this recommended section, the recommended section will recommend certain ideas based on certain relationship. Most of it, so this ontology parent is based on SNOMED hierarchy. So it goes up and down the SNOMED hierarchy chain and says, wait, this sounds something that you may be interested in. And based on that, it says, have you thought about inflammatory dermatosis? Now, I reviewed the clinical idea that you described, and I believe this would not meet your criteria because this is very, very broad. And here you're looking for the clinical idea of myositis and dermatitis kind of thing, which is not this idea. And then there is this lexical bias standard, and it just shows you polymyositis, but there is this idea called childhood type dermatomyositis. Have you considered this, or is this not the clinical idea?
We have. I actually refined the phenotype after I sent that document to specify adult dermatomyositis.
Perfect. Okay, perfect. So, so based on that, do you have anything that you would like to consider as part of your definition here, like disorder of respiratory system due to dermatomyositis? It's basically saying those were not part of your current expression, and it's your judgment call.
Yeah, I mean, I know this is like subjective and just content expertise, but no would be the answer. Okay,
and the other one is, okay, so there is no recommendation based on patient context. There is a new definition, new recommendation in 2.0, which is patient context. Essentially what it says is persons with this code also have this code. What do you think? Kind of recommendation. And that does not exist. There's no recommendation based on that framing here. So the other question I have is usually when you select a parent, you also select descendants. Is that of interest to you? Have you used descendants and used the vocabulary, the SNOMED grouping to do it?
We've explored that previously. I'm trying to remember the details of those conversations. I think that some of the descendants were not desirable in our phenotype. Hence that they were unclicked, but it's certainly something we can look into.
Yeah, again, there's no right or wrong. You're the subject matter expert here, but when you click on it, it brings out childhood type dermatomyositis, which you had said is not in scope, juvenile dermatomyositis, which is not in scope, and then there were a few more things that came up. So I'm not going to change it, but that's just an input for you. if you want to, you could change the logic and make this a little bit parsimonious by using the vocabularies acrobatics. Now, in terms of the two occurrences, this is what this logically resolves to is you could so this one, anytime a person has the code, every date the person has the code, they would enter. So if somebody comes today and comes back 10 days later and comes back 30 days later, they would enter, because here it says all events. So that means all the dates. The next rule here, which you have implied, basically looks for the occurrence of dates anytime before to up to 365 dates. And it will restrict all these this pool of dates based on this rule. The implication of this application of this rule is that if somebody gets the second code with after today's date up to 365 days in the future, they will stay in the cohort. But if they do not get it in the next 365 days, but they get it on the 366th date, then it would not be eligible. But it will cycle back and say, okay, does that same person have a second date? Guess what? The 366th date is now eligible. And the 366th day will meet this criteria because the day 0 is within this all days before rule. So what will happen in this implementation is it will shift for the person who has two codes more than 365 days apart. A small thing, but it might introduce a little bit of error. My recommendation for you, if you is either I do not think this rule will make a significant impact. I just want to bring it to your awareness.
No, thank you.
So the immunosuppressant medication definition, which says 180 days before to 180 days after, sounds reasonable to me. The one thing I would recommend you to do is to make this more parsimonious. It just looks a little heavier with 103 row items. You could probably select tacrolimus. If you select the ingredient, the things like Prograph will be part of it.
We actually, in a V2 that we didn't send, we actually tried doing this, and it what we discovered is that we essentially need to do a mixed approach for ingredient selection, because if we do a strictly ingredient-based immunosuppressant concept set list, it balloons to, like, I have it pulled up here, 19,000 concepts, to a point where it actually lags Atlas. So we need
let's talk this through. So and I think this will build up to our next step, which is the antibody. So just gonna pull this at random. Import your concept set here in the concept set segment of Atlas, and this is your definition. If I select tacrolimus and search for just the ingredient of tacrolimus,
I think the issue from our standpoint was we wanted to, the ingredient approach was flawed for a few reasons. One, we didn't want topical medications. that might include these. And second, I think it was the steroid that was the real problem child. The prednisone, corticosteroids, I think that was responsible for many of the thousands of drugs or concepts that we were getting. And we didn't want any of them. We just really wanted a much more narrow.
Perfect. Okay, so then we'll not dig on it further. So as long as you have a rationale for it, and you did it because of a reason, that is fine. I just wanted to make sure that you didn't do it because you did not know a functionality of something, and that was my only intent.
Thank you.
So next, which was the definition? All right, so we're back here. Okay, so now let's we have 20 more minutes. So here in antibody testing, one decision that we made, so we're not going to be, there's no recommendation to make any changes here or here or here. The change recommendation is to, well, the agreement that we had is to split this rule into two rules. So I'm going to just make a change here. The first step is to look at this and say, okay, so your implementation is you have to have a measurement, and that measurement should have a concept of positive or detected. This is the problem with this approach that we have observed is there is unfortunately there is no standardized way of representing results in the informatics space. There are many. Let me qualify that statement. There are many standard vocabularies, SI units, other units, and there are local units that are used by organizations. Because of that, when we have observed that that the word positive is represented 300 different ways, and the word detected is represented 300 different ways. And if you do not have the right positive, then you will not get any results. And that becomes really problematic when you're doing a network study, because you could probably run a query on your data source and understand how positive is represented in your data source, but you have absolutely no clue what another data source is doing. And so it is a problem, and it is an unsolved informatics problem, I believe. So data standardization, data harmonization on the results has been a challenge. So that might be one reason why you are not getting any hits on your data source, and it's definitely the reason why I didn't see any hits in the data source that I have access to. So to solve this particular problem, we have to either to solve that, we have to make this really broad and include pretty much every representation or positive in the OMOP CDF, and it's a challenge. So that's point number one. So before solving the results problem, let's solve the test problem. So like we can still do what we talked about, performed antibody test. We can review this result, and here it simplifies the rule into, so we simplified the rule, and here I'm going to remove the and it's over here. Okay, so I performed antibody test, and antibody test result is positive. When I responded to Danny Alhamra's post, I basically looked for performed the test and not the result. And that's what we are doing now in terms of performed the test. So before saving it, I would like to go through the antibody test concept set and confirm that this is comprehensive. I'm not going to lie. This looks, I don't even know what JO1 is, or PL12 antibody is, but you have to again, it's your subject matter expertise in saying you're comprehensive enough. And again, when you think about comprehensive enough, you have to say, all right, have I You have to think about every possible way any data source in the world would represent this.
Right.
I tack on a comment to that, Gowtham. Hey, Christopher, Andrew, and Noel here. If you notice there, you've got presence as well as units by volume.
Yes.
When we're talking about present and detected or positive and detected, that units by volume, these kind of measurements will be very difficult. Someone will have to actually compare the units by volume to any reference ranges returned by a lab and then determine whether it's positive or detected. That can actually be very difficult. So depending on what's the most common drawn in here, if you've got a lot of units by volume, your query may be failing just because these are not reported in a positive or detected manner from the lab.
Ah, okay. So yeah, so you're basically saying that this is a quantitative, this is a number, well, units by volume, and you cannot apply the yes or no or positive, negative, detected, undetected rule on a number.
I mean, I guess on a data set by data set, potentially, if you know that if you've determined what unit by volume means positive or detected in your system, maybe, but when you're looking out over data sets that are getting data from potentially a variety of labs, a variety of hospital systems, a variety of different data sets, that challenge might become insurmountable.
Yep.
Does it make sense to remove them, or is there a harm in including them, I guess?
Depends. If you're using an any logic, then the only harm would be if your test results are returning you a portion of the population that you didn't expect. And a lot of these antibodies, kind of looking at them, like Gowtham, some of these I don't know what they're testing for, but I've got up to date up on my other screen looking at the types of antibody testing we do for inflammatory myopathy, specifically dermatomyositis, and some of these I don't recognize. So you might be over including with some of these, but I'm not sure.
Yeah. Okay.
Thank you.
Yeah, so this is a hard challenge, Christopher. And we recently, as part of the Neutropenia post, we attempted to tackle the lab results. And neutropenia is much more common compared to this antibody testing. And even that was difficult. So I'll bring up the neutropenia definition just as illustrative example. So this is how it would look like for a neutropenia. If you in neutropenia, because people can enter either because of a diagnosis, or that is condition occurrence, or a measurement. But the measurement could be in different scales. The units could be billion per liter, 1,000 per microliter, which is equivalent, million per milliliter, which is equivalent, 1,000 per cubic milliliter, billion cells per liter. And then we said it's neutropenia, so it has to be less than 1.499 in that unit, but more than 0, because 0 could mean negative. Right? So we don't want 0 because they have data quality issues. We know that 0 represents 1 or 0 usually means yes or no. And then on another scale, it was cells per microliter and per microliter. And there we said,
sorry, Gowtham, do you mind if I jump in one more time here?
No, go ahead.
One other thing with measurements like this that can be so difficult when we're looking for a quantitative number is a lot of labs will result something as less than, and a less than when it comes in as a string instead of a numeric value. And then you actually have to translate that string back to numeric, and it's not something that a lot of lab systems will do. So you very well might be getting non-numeric results in here that to the human eye look numeric, but we'd also have to translate that. So if it comes back as a less than value, what does that mean?
Yeah.
So that can be very tricky. And also some of these billion, thousand per liter, microliter, oftentimes labs also send these back with special characters. And depending on how you're translating those special characters, they can be quite difficult to parse as well.
That's right. And this is not a challenge of Odyssey or the tool. This is a global informatics challenge. And because this definition require, if we continue down the path, and I encourage you to continue down the path of using results as part of the definition, these are the challenges that needs to be tackled.
No, this is really helpful. I mean, I think I'm only starting now to appreciate the complexity of the results issue. I mean, I will say when I speak to other researchers, usually clinicians, about like, you know, these tools and this method of research, one of the main criticisms is that their phenotypes are too crude. Like, it's great that we're looking at dermatomyositis, but like, that's not enough for us. We want dermatomyositis who have this particular antibody or this particular white blood cell count, and that we want to study that more homogeneous group. So it's nice that there is an answer, although it's complex and a work in progress, it sounds. But I think that's good for me to know as I move forward.
Yeah. So if you in your data source, so you have the following alt options, I think, to pursue the lab results. You have an OMAP instance of a specialized data set. You could query a raw SQL query on that data source and look at how your data source populates these results. And you could build a definition that is custom and works for your data source. And that itself is a huge win. The next order problem is to see how you can generalize that learning to other data sources like the Epic systems or the data source that we have licensed to or others in Odyssey network. So second order problem. And the learning there could be, this is not generalizable. As soon as you apply lab results, you need a specialized data set. And that could be a fair conclusion. But I think with rule number 3, if you learn that the performance characteristics of a cohort definition that limits itself to rule number 3 has a sensitivity of 80% or 80% and a specificity of 80%, but by applying your lab result, you have a sensitivity of 70% and a specificity of 90%, you may say, the trade-off is acceptable.
Right.
And that type of framing would be useful. You know, to think about. So we got 7 more minutes. So we could now spend some time, you know, picking, or you can do it yourself too. Pick and choose the antibody. So actually, let's talk about the next step. So no changes here for your specific definition. We talked about this particular split, and I showed you how to do it. It's very easy. Look at the antibody tests. Andrea suggested maybe, as a fellow clinician said, maybe there are some of these you may want to look into. You are the expert, you know, and you confirm it. And then this one, if you want to pursue this, you will need to look at the result distribution on your particular data source and make a decision based on what you observe. And for that, you'll either have to write a SQL query, or there are actually other data quality tools in Odyssey that like Aries and Achilles that can help you with some summary information to show you, okay, for this particular test, what are the various units that are in your data source? What is the distribution of the results set based on the units? And those can inform you in making choices here.
Very helpful.
Right.
so I just wanted to ask if Zach or Will have any, as we approach the end of the hour here, do you guys have any other questions, given the people here and the help?
This has been very, very useful.
Absolutely.
Awesome.
This is
Also going to thank Gowtham and everyone with the Phenotype team for taking the time today. I think we got a lot of good actionable items going forward, and it is good to confirm what's causing these issues with our phenotype definition. And yeah, very happy presenting and having this critique being done. It's very helpful for our work.
In terms, yeah, just one more comment. So, sorry. In terms of Phenotype February to make progress, you still have your sensitive definition. And that sensitive definition, which we talked about, which is basically entered by a code and then another code in the 365 days, you have results on that, on this particular app. And it has been run on data sources that I have access to. So you could look at those in the typical way that has been done in the last 5 days and still communicate your findings and say, but I'm not satisfied with it. I want to make progress by using the lab results and so on because of these reasons. So you could still do and communicate. You have information, sufficient information to continue the Phenotype February conversation. In terms of the insights that we got about lab results, pursuing that, that's like Andrea said, that's a hard challenge. It's going to take time. It's not solvable in 2 days.
This is awesome. Thank you guys so much. This is wonderful.
Awesome. All right. Welcome to join the 10 o'clock call. We are going to be talking with Dr. Mirza Khan about his ideas around ST elevated myocardial infarction. Thank you, guys.
Thank you.
Thank you.